Hari Om. Hello everyone, I am Srijyoti. Welcome back to my channel. Today's video is of class 12 mathematics chapter 11 three-dimensional geometry. In class 11 we studied introduction to three-dimensional geometry. That is, in three-dimensional geometry points are represented using three coordinates, say x, y, z. X, y, z. Each coordinate corresponds to a position along x-axis, y-axis and z-axis respectively, right? So here in our previous chapter we have studied some concepts of vectors. So here we will use this vector algebra to three-dimensional geometry. Okay, and in 11th standard we studied that how to write the equation of a line in three-dimensional geometry in Cartesian form. Okay, but in this chapter we will study equation of a line in three-dimensional geometry in vector form and also in Cartesian form. Okay, and also we will study finding the angle between two lines and shortest distance between two lines in vector form and also in Cartesian form. Okay, first of all, here we will study direction cosines and direction ratios of a line. We have already studied in the previous chapter, that is in vector algebra. So here let alpha, beta, gamma are the direction angles of line L, and pi minus alpha, pi minus beta, pi minus gamma are the direction angles of line that is made by this line in opposite direction. Okay, and direction cosines, cos alpha, cos beta and cos gamma. Okay, cos alpha, cos beta, cos gamma are the direction cosines, and what is the relationship between them? Cos square alpha plus cos square beta plus cos square gamma is equal to 1. Okay, these all things we have already studied in vector algebra. See, if you have any doubt, you just to go through vector algebra chapter. Okay, so here cos square alpha plus cos square beta plus cos square gamma is equal to 1. And we named this cos alpha is equal to L, cos beta is equal to M and cos gamma is equal to N. Therefore, L square plus M square plus N square is equal to 1. Okay, and let lambda be a non-zero scalar, then lambda L, lambda M, lambda N are the direction ratios of a line, and here we represent the direction ratios as A, B, C. Here A is equal to lambda L, B is equal to lambda N, C is equal to lambda N. Okay, alpha, beta, gamma are the direction angles of L. Okay, directed line L, and pi minus alpha, pi minus beta, pi minus gamma are the direction angles of L in opposite direction. Okay, and this cos alpha, cos beta, cos gamma are the direction cosines of the line L. If it is in opposite direction, what are the direction cosines? Cos pi minus alpha, that is minus cos alpha, minus cos beta, minus cos gamma are the direction cosines of the line in opposite direction. Okay, and we know we have already studied the relationship between them. Okay, that is cos square alpha plus cos square beta plus cos square gamma is equal to 1. It's very important relationship between direction cosines of a line. Okay, that is cos square alpha plus cos square beta plus cos square gamma is equal to 1. Okay, if cos alpha is equal to L, cos beta is equal to M, cos gamma is equal to N, then L square plus M square plus N square is equal to 1. Now let's see how to find direction cosines when direction ratios are given. Let A, B, C be the direction ratios of a line, and let L, M, N be the direction cosines of the line. Okay, and we have A is equal to lambda L. Lambda is a non-zero scalar. Okay, A is equal to lambda L, B is equal to lambda M, C is equal to lambda N. Okay, then here A square plus B square plus C square is equal to lambda L whole square plus lambda M whole square plus lambda n whole square, right? So take lambda square outside. Lambda square is the common, okay? So lambda square into L square plus m square plus n square, that is equal to lambda square. Why? Since L square plus n square, m square plus n square is equal to 1. Okay. So here we have got a square plus b square plus c square is equal to lambda square. Therefore lambda is equal to plus or minus square root of a square plus b square plus c square, right? Okay. Now here we will find the direction cosines, right? So direction cosine L, M, N are the direction cosines of a line, right? So L is equal to, L can be written as A divided by lambda, right? A divided by lambda. M is equal to B divided by lambda. And N is equal to C divided by lambda. How to find lambda? Lambda is nothing but plus or minus square root of A square plus B square plus C square. Therefore, L is equal to plus or minus A divided by root of A square plus B square plus C square. M is equal to plus or minus B divided by square root of A square plus B square plus C square. And N is equal to plus or minus C divided by root of A square plus B square plus C square. Okay. So this is the method to find the direction cosines of a line when direction ratios are given. Now let's see how to find direction cosines of a line passing through 2 points. Okay, see here when direction angles are given, we can find direction cosines, right? When direction angles ratios are given, we can find direction cosines. So how to find direction cosines of a line when 2 points are given? Okay, so here let's take 2 points. Let P of x1, y1, z1 and Q of x2, y2, z2 be the 2 points of a line. We have to find direction cosines of line PQ, right? Okay, so for that, first of all, let's write position vector of P and Q. Position vector, vector OP, okay? The vector from the origin, okay? Position vector of P from the origin, that is vector OP, that is equal to x1i plus y1j plus z1k. We have already studied in vector algebra, right? Okay. So next vector OQ is equal to x2i plus y2j plus z2k. So vector OP and vector OQ. Next we need to find vector PQ, okay? Vector PQ. What is vector PQ? By triangular law of vector addition, vector PQ is equal to vector OQ minus vector OP, right? That is x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 k, right? So here we have got vector PQ. We have to find the direction cosines of a line PQ, right? See, what are the direction cosines? It's nothing but it is the components, okay? Components, that is or coefficients of I, j, k, unit vectors, that is components of unit vector along the vector PQ. That is direction cosines of vector PQ, okay? Direction cosines of line PQ, that is nothing but components of unit vector along vector PQ. So here we need to find unit vector along vector PQ, okay? Unit vector along vector PQ, okay? Remember, direction cosines are nothing but components of unit vector along vector PQ, okay? So that is equal to, how to find unit vector along PQ? That is vector PQ divided by modulus of vector PQ, okay? That is equal to, here vector PQ is x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 k divided by modulus of vector PQ, that is square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. It is the unit vector. Okay, that is x2 minus, split it, x2 minus x1 divided by square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square I, okay, plus y2 minus y1 divided by square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square j, okay, plus z2 minus z1 divided by square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square k. So here coefficient of I is x2 minus x1 divided by this one. Okay. So here direction cosines are, one is x2 minus x1 divided by this one. Okay. x2 minus x1, that is coefficient of I, x2 minus x1 divided by x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay. Next, coefficient of j, that is y2 minus y1 divided by square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay. Next, coefficient of k, that is z2 minus z1 divided by root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay, these are the direction cosines. So here remember, when 2 points of a line are given, the direction cosines are x2 minus x1, x1, y1, z1, x2, y2, z2 are the points of a line. Okay. Then direction cosines are x2 minus x1 divided by square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. And y2 minus y1 divided by root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. z2 minus z1 divided by root of x2 minus x1 plus whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. These are the direction cosines of a line passing through 2 points. Now let's go through exercise 11.1. First question. If a line makes angles 90 degree, 135 degree, 45 degree with the x, y and z axis respectively, find its direction cosines. Directly we can find, that is alpha, beta, gamma, that is direction angles are given 90 degree, 135 degree and 45 degree. So direction cosines are cos 90, cos 135 degree and cos 45 degree. That is direction cosines are, what is cos 90? Cos 90 is 0. Cos 135 degree. How to find cos 135? Cos 135 can be written as cos of 90 plus 45, right? So cos of 90 plus, since it is 90, cos will become sine, right? So sine, and what is the sine of here? 90 plus, that is it lies in second quadrant, 90 plus, right? So since it lies in second quadrant, cos is negative, therefore minus sine, okay? Minus sine 45, that is minus 1 by root 2. Sine 45 is 1 by root 2. Therefore minus 1 by root 2. And cos 45 is 1 by root 2. Therefore direction cosines are 0, minus 1 by root 2, 1 by root 2. Look at an important question. Find the direction cosines of a line which makes equal angles with the coordinate axis. Okay, see here angles are not given, but one condition is given, all the angles are equal. Okay, angles made by this line are equal. Okay, so here let's take, let alpha, beta, gamma be the direction angles of a line. Okay, and since this line makes equal angles with the coordinate axis, here alpha is equal to beta is equal to gamma, because it is given that here line which makes equal angles with the coordinate axis. Okay, therefore alpha is equal to beta is equal to gamma. That implies cos alpha is equal to cos gamma is equal to cos beta is equal to cos gamma. That implies L is equal to M is equal to N. Right? These are the direction cosines. Okay. Then here we have a result L square plus M square plus N square is equal to 1. Right? That implies here L is equal to M is equal to N. Therefore here we can write L square plus L square plus L square. Right? That is 3L square. That is equal to 1. That implies L square is equal to 1 by 3. That implies L is equal to plus or minus 1 by root 3. Okay. See, we have got L. That is a direction cosine, right? So here L is equal to plus or minus 1 by root 3. Here we have L is equal to M is equal to N. Therefore, the direction cosines are plus or minus 1 by root 3, plus or minus 1 by root 3 and plus or minus 1 by root 3, because here we have L is equal to M is equal to N. So these are the direction cosines of a line. If a line has direction ratios minus 18, 12 and minus 4, then what are its direction cosines? We have formula, right? So here direction ratios are given. Suppose ABC are the direction ratios, then direction cosines are A divided by root of A square plus B square plus C square and B divided by root of A square plus B square plus C square, C divided by root of A square plus B square plus C square. Here direction ratios are minus 18, 12, minus 4. Therefore, here we need to find root of A square plus B square plus C square. That is root of minus 18 square plus 12 square plus minus 4 square. That is square root of 324 plus 144 plus 60. That is equal to square root of 484. That is equal to 22. Okay. Therefore, direction cosines are minus 18, that is A divided by root of A square plus B square plus C square, right? So A divided by 22, that is minus 18 divided by 22, 12 divided by 22 and minus 4 divided by 22, that is minus 9 by 11, okay, 6 by 11 and minus 2 by 11. These are the direction cosines of this given line. Show that the points 2, 3, 4, minus 1, minus 2, 1, 5, 8, 7 are collinear. We know that 3 points are collinear, then these 3 points should be lying on the same line, right? Or the line joining these points are parallel, right? So here we have to show the line joining these points are parallel. So how to show this one? See here, we know that direction ratios of the line joining these points are proportional. Then we can say the line joining these points are parallel. Okay, so here we need to find direction ratios of the lines joining these points. Okay, so here let's take A, B, C are the points. Then let's find direction ratios of line AB. Okay, these are the points A of 2, 3, 4 B of -1, -2, 1 and C of 5, 8, 7 be the points. Okay. Then line AB, direction ratios of line AB is equal to, how to find direction ratios of 2 points? That is, if 2 points are x1, y1, z1 and x2, y2, z2, then direction ratios of these points, that is direction ratios of a line joining these points are x2 minus x1, y2 minus y1, z2 minus z1. Okay. Remember, direction ratios of a line joining the points x1, y1, z1, x2, y2, z2 are x2 minus x1, y2 minus y1, z2 minus z1. Okay. So here we are going to show the direction ratios of the lines are proportional. Okay. So here let's find direction ratios of the line AB. That is -1, -2, -1, -2. Okay. -2, -3, -2, -3, 1, -4. 1, -4. That is equal to -3, -5, -3. Okay. So here these are the direction ratios of the line AB. Next let's find direction ratios of line BC. Okay. Direction ratios of line BC. Okay. That is direction ratios of a line joining the points -1, -2, 1, 5, 8, 7. Okay. Are 5 minus -1, that is 6. Okay. 8 minus -2, that is 10. 7 minus 1, 6. See here, it is -3. So here we can write, see -3, it is 6. Right? -5, -3 into -2, that is 6. Right? -5 into -2 is 10. -3 into -2, that is 6. Therefore, direction ratios of line AB and line BC are proportional. Right? Therefore, line AB and BC are parallel. Hence, points A, B, C are collinear. Okay? Hence, the points A, B, C are collinear. Find the direction cosines of the sides of the triangle whose vertices are 3, 5, -4, -1, 1, 2 and -5, -5, -2. See here in this chapter we have already studied how to find the direction cosines of a line joining two points. Suppose it is a line joining the 2 points x1, y1, z1, x2, y2, z2. Okay. Now how to find direction cosines of the line joining these points? That is, direction cosines are x2 minus x1 divided by root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Next is y2 minus y1 divided by root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Next is z2 minus z1 divided by root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So that is these are the direction cosines of the line joining these 2 points. Okay. See here, what is in the denominator? See this denominator, root of x2 minus x1 whole square, y2 minus y1 whole square plus z2 minus z1 whole square. It is nothing but distance of this line joining these 2 points. Right? It is the distance, right? Distance of this line joining these 2 points. So here this one we have already studied in 11th standard, that is distance between these 2 points in 3-dimensional geometry. Okay. So here we have to find, in this question we have to find direction cosines of each sides of the triangle joining these points. These are the vertices of a triangle. Okay. So let's take, let A of 3, 5, minus 4, B of minus 1, 1, 2, and C of minus 5, minus 2 be the vertices of triangle ABC. Okay. So here we have to find the direction cosines of each sides of this triangle. Okay. That is direction cosines of AB, direction cosines of BC, direction cosines of AC. Suppose it is the triangle ABC. Here we have to find direction cosines of AB, direction cosines of BC, and direction cosines of AC. Okay. So let's find. So here, to find the direction cosines, here we need to find distance, right? Distance of AB, distance of BC, distance AC, right? That is length of AB, BC and AC. So first of all, let's find length AB. Okay, that is equal to, how to find? X2 minus x1 whole square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, right? So let's find minus 1 minus 3 minus 4 square 16, right? Plus 1 minus 5, that is minus 4 square 16, plus 2 minus 4, that is 2 plus 4, 2 square is 4, right? That is equal to, 6, that is 2 minus 4, so 2 plus 4, that is 6 square 36, that is equal to square root of 68, that is 2 root 70. Okay, so its distance, that is length of this AB is 2 root 70. Okay, length AB is 2 root 70. Next, let's find BC. Okay, to find the direction cosines of BC, here we need to find the length of BC, right? That is square root of BC. These are the points. Okay, so here x2 minus x1, that is minus 5 minus 1, that is minus 4. So minus 4 square is 16. Minus 5 minus 1 minus 6 square 36 plus minus 2 minus 4 square 16. That is also is equal to square root of 68. That is equal to 2 root 70. So length BC is 2 root 70. Okay. Next we need to find length of AC. Okay. Third side. So AC is equal to square root of, these are the points, right? So minus 5 minus 3 minus 8 square 64. Minus 5 minus 10 square 100, right? Plus minus 2 minus 4, that is plus 2, right? So plus 2 square 4, that is equal to root of 168, that is equal to 2 root 42. 42 into 4 is 168, right? Okay. So this distance, that is length of AC, is 2 root 42. Okay. Now we will find direction cosines of each sides of this triangle. Okay. What are the direction cosines? First we will write direction cosines of AB. Direction cosines of AB are, that is x2 minus x1 divided by length, right? That is here x2 minus x1, that is minus 1 minus 3 minus 4 divided by AB, that is length of the side, that is 2 root 70. Okay. Next y2 minus y1, 1 minus 5, that is minus 4 divided by 2 root 17. Next is, sorry, this one, okay. 2 minus 4, that is 6. 6 divided by 2 root 17, that is equal to, reduce it, minus 2 divided by root 17, minus 2 divided by root 17, here 3 divided by root 17. Okay, these are the direction cosines of side AB. Okay, next we will find direction cosines of side BC. Direction cosines of side BC are, these are the points, right? So minus 5 minus 1, that is minus 5 plus 1, minus 4 divided by length of BC 2 root 17. 2 root 17. Next is y2 minus y1, that is minus 5 minus 1 is minus 6. Minus 6 divided by 2 root 17. Next minus 2 minus 4. Minus 4 divided by 2 root 17. Okay, that is equal to minus 2 by root 17 minus 3 by root 17 minus 2 by root 17. Okay, these are the direction cosines of side BC. Next we will find direction cosines of side AC. Okay, direction cosines of AC are, these are the points, minus 5 minus 3 minus 8 divided by length of AC is 2 root 42. Minus 5 minus 10 divided by 2 root 42. Minus 2 minus 4, that is plus 2. 2 divided by 2 root 42. That is equal to, here, minus 4 by root 42, minus 5 by root 42 and 1 by root 42. These are the direction ratios of side AC.